Good evening to all the distinguished participants, respected faculty members, and invited guests. I am Dr. Ayani Nandi on behalf of Ramgarh Engineering College. Truly delighted to welcome you all to day 3 of our faculty development program on alternative fuels and hydrogen energy, clean energy innovations for a sustainable society. After an enriching and insightful second day, we are excited to continue our journey of learning, exploring, and knowledge sharing. Today's session promises to bring even deeper perspectives, practical understanding, and expert driven discussion that will further strengthen our grip on the emerging trends and innovations in the domain. Your active participation, curiosity, and engagement have made day 2 truly successful. And we look forward to the same enthusiasm throughout today's schedule as well. Let us begin day 3 with new energy, open minds, and a shared commitment to advancing our academic and professional excellence. Wishing everyone a productive and inspiring day 3 for the FDP. On behalf, I take great pride in extending a warm and heartfelt welcome to our respected guest, Dr. Priyatam Kumar Sir, Professor in the Department of Electronics and Communication Engineering at KLE Technological University, Hubli. Dr. Priyatam Kumar Sir is a highly accomplished academician and researcher with over 25 years of rich experience in the fields of artificial intelligence, Internet of Things, embedded systems, and sustainable energy technologies. Over the years, he has contributed immensely to advancing smart and energy efficient systems through the integration of intelligent computing and IoT based automation. Dr. Priyatam Kumar Sir expertise as a professor with 25 years of experience likely focuses on how to use AI and the IoT to create more efficient and sustainable energy system. This includes smart energy management for microgrids, residential settings, and large-scale smart cities, optimize renewable energy integration, and improve overall energy efficiency. His extensive research and teaching experience have helped bridge the gap between the emerging technologies and sustainable engineering practices, inspiring students, researchers, and professionals. Dr. Kumar Sir expertise lies in developing intelligent framework and IoT-based solutions that optimize energy use, promote renewable integrations. The application of his research and innovations are smart cities, implementing systems like smart green energy system for fine-grained control of energy use across various urban sectors. Note this E3S Web of Science conference. Another innovation is creating microgrids, creating advanced energy management system for microgrids that can use AI to predict weather impact, optimize battery storage, and improve financial saving. And also residential and industrial settings, developing systems for accurate energy monitoring and load management to promote conservation and efficiency. The aim of such work is to achieve significant energy saving, battery integration of renewable energy sources, reduced waste, and contributed to broader environment goals like those in the United States Sustainable Development Goals as highlighted by ResearchGate. On behalf of Ramgarh Engineering College, I, Dr. Ayani Nandi, once again extend a warm welcome to you, sir, and express our sincere gratitude for gracing the FDP with your expertise and presence. I also take this opportunity to welcome all the participants, faculty members, and dignitaries who are part of this important academic initiative aimed at promoting innovation, sustainability, and technological advancement. May I now request you, sir, kindly share your thoughts and inspire us with your words. Sir, you can start now.
Yeah, thank you very much, madam, for the introduction. Am I audible,
Thank you, sir.
madam?
Yes, sir. Yes, sir.
Yeah, okay, thank you. Today, I'm talking on the IoT for sustainable energy management. So, as we are talking about the energy management, whenever we are talking on the energy, we will have the hydraulic energy, we will have the solar energy, we will have the wind energy, and we will have the battery energy where the stored energy can be used for the system. Now, the interesting part of the system is whenever I'm using this energy, to what extent or to what level I'm trying to use the energy. So, if you look at one simple example of the home applications, so whenever I'm talking about the home application, we have the lighting system, we have the refrigeration system, we have the microwave system, we have the other appliances like air conditioner and other appliances which we are trying to use in the system. So here the question is, are we using all these equipments in the proper manner? Most of the time the answer is no. Because if I'm using a room, in that I would like to have the fan, I would like to have the AC, or I would like to have the proper lighting system in the room. If I leave the room, what will happen? Have I switched off everything and go out? Or I will keep the things as it is and move out. So here the second part is, if I leave the things as it is and I'm moving out, it means that we are not utilizing the energy in the proper direction. So hence we are losing the energy. That means when I'm not using it, I should have switched off or I should have made the alternative arrangements, but which I am not doing. So I am wasting the energy. So whenever I'm saying the wasting of energy means we are leaving the carbon footprints. That means if I'm using something for a particular application, for a particular usage, it is appreciable. If I'm not using, but I'm using the resources, that means I'm losing the energy. So here our interest is how to manage these things. Somebody has to manage these things. So now most normally what happens at the residential places is mother or the elderly people will take care. If somebody is not there in the room, he will switch off the fan, the light, everything. But somebody has to take care of this. So that's the reason why we are going for Internet of Things. So here we are trying to make use of some smart system through which we are trying to control all these things, and in turn we are saving the energy. It very clearly says that if you save 1 unit of energy, it is equivalent to production of 2 units of energy. If energy is utilized properly, then the quality of life is much better. So now there is a saying that whatever the energy, hydraulic energy I'm talking about, is produced in the grid level, the transmission process, it is going to lose at about 20 to 23% of energy in the resistance. Just Ohm's law, V is equal to I into R. So we are losing, but it is getting converted into heat and we are losing in the transmission process. So there are several techniques has come up. So from the grid, there is an effort is going on to have the wireless process. That means the energy has to get transmitted by means of wireless system. A lot of research is going on that. And once it is through, that means the transmission, the losses can be minimized. So that's one part. Second part is most of the energy is used by the consumers. Whenever you are using the energy, how you need to control this energy such that there should not be any loss, or it has to be optimally used or effectively and efficiently used in the practice. So there is two part. One is artificial intelligence and the second part is IoT. So whenever I'm talking on the IoT, it got a setup where it it looks the overall performance of the system, getting the energy, converting it, using it through the cloud or somewhere else. You are getting the data and working it out. So whenever I'm talking with the cloud or something like that, I need to effectively identify where my data is located. And I have to fetch that data and use that one. So for that particular purpose, we are trying to make use of the artificial intelligence. So the artificial intelligence will provide us the algorithms, and IoT will give us the hardware solution. When we club these two, it becomes the firmware, and through which we are trying to get some effective means such that we are able to save the energy and which can be utilized for some other purpose, and which will reduce the uh, carbon footprints which we are having a lot of losses can be minimized. So today in my talk is how the IoT is going to be used and what are its constraints, advantages, disadvantages, and what are its components, and how making use of the IoT we are able to get a proper utilization of the energy and how we are managing this energy. So let us start with the fundamental thing. So here, if I look at the, I'm not able to move this to the next slide. Yeah. Okay. Now, if you look at into the AI and IoT. So as I told, the artificial intelligence and Internet of Things technologies, which are got an potential way to manage this energy systems. That is one part. Second part is the sustainable energy management. Sustainable energy management will talks about the goals and importance of sustainable energy management. Whatever the means of energy we are trying to produce, hydraulic, solar, wind, or any stored energy, how we are able to make it sustainable for the application purpose. So that's the main goal of our system. So now, what is this? Why we need the energy management system? The basic question. So whenever I said, whenever we are using any energy, it has to be used optimally. We have to use optimally. And whenever I'm trying to use it optimally, how best I can convert from one process to the other. So the AI and IoT based energy management system collects the data on energy consumption and the applies to the real analytics. So it says that for any application, say for example, if I'm using for household purpose, normally we say that it is 3 kVA. That is the amount of energy, maximum energy what we can utilize from the grid. So when I'm getting 3 kVA, how optimally I can use the system? It's very clear that can I put the entire load simultaneously onto the system? That means I have to switch on my air conditioner, switch on my motors, switch on my lighting system, switch on my fans, everything. That means it is the maximum load. That is one option. Second option is, can I use only the things which are essential for that moment, which are essential for only for that moment. If I want to try to use only such kind of things, then I need to collect the data. So the data collection is that when I'm going to use maximum power and when I'm not going to use maximum power. Say, for example, in the daytime, if I got a proper ventilation system, I may not use the lighting or I may not use the fans. So I have to discriminate the things like when I'm going to use these equipments and when I'm not going to use these equipments. So that is the data. So over the period of 24 hours, if I'm able to get this kind of data, when and what kind of energy I'm consuming in my real life. So that is what I need to look into. And then these resources, whatever I am trying to use, I have to use some strategy such that a uniform distribution of a load onto the grid has to happen. Otherwise, what will happen if I am trying to use more than the desired value? There is a possibility that the system will get into the cutoff. If nowadays we got the cutoff systems, once if you go beyond certain limit of your capacity, then automatically it will get tripped. So when it is get tripped, I am uncomfortable because I am trying to use it, but it is getting tripped. I am uncomfortable. So here I have to minimize that uncomfortableness in the system. So that is where I need to look for some strategies. Through the strategies, how I am able to work out the things. So it is very clear. Now I have to have a, a database. So in the database, from 0 to 30 days, so 1 month period. And in that, I have the classification of daily consumption. And in the daily consumption, further, I'm reducing it into hourly consumption. So in the hourly consumption, what is happening over one day from midnight 12 o'clock to the next day midnight 12 o'clock, when and what all the kind of energy, to what level I'm using the energy in the system. So I have to make the chart prepared for that particular thing. So once if I'm able to get that grant chart, then I have to work it out for the month. So that is where the utilization in the real time, the energy utilization in the real time I'm able to get, and then how to manage these things, how to manage with these things. So that is where the strategies has to come into the picture. Okay. Then now we will see the process of IoT, which can go for the time energy monitoring. So in the time energy monitoring, we have the first part is IoT sensors. So this is IoT sensors are able to collect the real-time data on energy usage from various equipments and the systems. Sensors are those, we will call them as the converters from one form into the other form. So here we are converting the energy into the voltage. So this voltage is going to be used for defining the various conditions. So sensors are the transducers which are going to convert from energy from one form to the other form. So here we are converting energy into the voltage level. That voltage level is further used for processing the things. And second one is the smart meters. So these smart meters, see, look at the earlier meters, the difference between earlier meters and the smart meters. Earlier meters, what used to happen, whatever you are using, it is keeps on showing you the readings. So what we can see is how much energy we have consumed per hour or per day or per month. That we are able to see it with respect to the general earlier meters. And now here we are going to have the smart meters. So the smart meters will try to give you the feedback. So it is not a open loop system, it is a closed loop system. So in the closed loop system, it provides you the instant feedback on the consumption on your phone or on your any electronic device which you are connected through. So it tells that for this moment, your energy consumption is very, very high. So I can realize, okay, I have done switched on so many things. Now I have to switch off them. So by means of the feedback, I am able to detect where exactly I'm trying to consume more power. Can I reduce that power? Or can I switch it off such that I can get into the allowable range? So these smart meters will give you the instant information regarding the consumption of your usage. And third one is the cloud computing. So cloud computing, earlier I told you, I want to see the things with respect to hour basis energy, day basis energy, or monthly basis energy, or yearly based energy. So when I'm working with all these things, the data is going to be produced. So where I have to store this data, because there are not a individual or a single data process is going to be accessed. There are going to be the multiple system. Lakhs or crores of people are using the system. The data is going to be enormously large. So here we are trying to use the cloud. So cloud is able to use or store the energy, and from that cloud, whenever is required, I can fetch the data and I can process the things. Now, the thing is, I'm storing the data into the cloud. So, in the cloud, the data is going to be very large. Say, example is if I talk about the library. Now, I want a particular book. If I get into the library, can I get easily that book? Answer is no, because it has to be located in a particular location, and I have to go to that location and get it, and I should know where that book is available. So what I am trying to do there, I am trying to use the computer and typing the book name, then it will give me the shelf number and other details. So straight away I can go there and pick that book. That means the access time which I am trying to use to access the data in the library is becomes faster. In any system, the accessibility, or we'll call it as the bandwidth, it has to be faster. So the access time has to be very, very less. That means I am able to process the data at the faster methodology. So when the data is very large, like in the library, when I'm looking or searching for a book, it becomes a tedious job. If I start with the book number one and keep on searching, it will take a lot of access time. How to reduce that access time? So here we are trying to make use of the artificial intelligence or machine learning process. So the artificial intelligence and machine learning process, it will predict, it will predict when you are going to use more energy, when you are going to use the less energy. So there are algorithms. Through the algorithm, it will try to predict when you are going to use and when you are not going to use, because you have the daily routine data is already available in the cloud. So based on that, it has to fetch or take the process and then optimize the consumption. So optimizing consumption means it will tell you, it will provide you the information saying that in this particular, say your geyser is on for a quite long time. Normally it is geyser has to be used for 10 minutes, but already it is 15 minutes. Still you are not switched it off. So that kind of data is optimizing. So it is intimating you that switch off your geyser. If you have forgotten sometime, you can go and switch off the thing. So the artificial intelligence or the machine learning will try to, through the algorithm, it will predict, and then it will optimize, then it will talk about the amount of energy consumption in the system, and it will detect the anomalies. Anomalies is when you are not using. Say in my room, AC is on, but nobody is there. It is a waste of energy. So it will detect